Hi, this is Mr. Chu and I welcome you to my channel. If today is your first time, then I want to encourage you to subscribe to this channel for more videos. In the last video, I gave an introduction to circle theorem and I promised to take the theorems one by one. Let's go straight to theory 1. Thank you. Theory 1 says that the angle a chord subtends at the center of a circle is twice the angle it subtends at the circumference of the circle. Taking chord AB from the first circle here, you see that AB subtends an angle X at the center O, and the same chord subtends an angle Y at the point C at the circumference of the circle. This first theorem is saying that whenever you have a situation like this in a question, you will be given either X or Y, and the relationship between them is that twice Y will be equal to X, that is 2Y will be equal to X, or anyhow you want to put it, S equals 2Y. The same way, if you want to make Y the subject, you divide both sides by 2. That means Y will be equal to 1/2 X. If the angle at the center is given to you, you divide it by 2 to get the angle at the circumference. The same way, if the angle at the circumference is given to you first, you multiply it by 2 to get the angle at the center. Coming to the second example here, it means that the angle, because the same chord here is CD, so it means that the angle subtended at O, which is the center of the circle, will be twice. So let me just write that angle COD equal to twice theta. So that is the application we are going to have. Then the third example is just to tell us that it's not always that the angle at the circumference will be at the top, but it can be anywhere. It can be anywhere along the circumference of the circle. That's number 1. Then number 2, it's not always true that the chord will be shown. So here is chord MN, but you've seen that they didn't connect it. We just have the point M and N. So maybe if you are having problem, you can just use broken lines to connect the chord MN so that you can see it well. Then the first part I explained that not always that the angle subtended at the circumference will be at the top. So here it appears lower than the center of the circle, but the fact that it is the same chord MN that is subtending this angle at the circumference, theorem 1 still applies. So we can just use this as a way of providing answer to the question. That means angle MPN is going to be half of angle MON, which is the center of the circle, 60, and that is going to give us 30 degrees. You mean that the angle MPN is 30 degrees because the angle MON is at the center of the circle and both of them are subtended by the same chord. Yeah, so that is what the first theorem says. Let's try proving the theorem using GeoGebra. This is our GeoGebra interface, and we'll sketch our circle quickly. So here you have our circle. Let me center it well. All right. So we have our circle with center A and a point B on the circumference of the circle. Now let's sketch our chord CD. Yeah, there you have it. With chord CD, we are going to subtend an angle at the center A and then another angle at the circumference B. So there you have your angle at the center, and then let's go to the angle at the circumference. All right, so there you have it too. Right, so what we are going to do right now is to measure the angle at the center and that of the circumference to see whether the relationship between them is very true. So let's do that quickly. Good. So the angle at the center is 62.4. Let's check the circumference. Right, and that is 31.2. 31.2. All right, so that is the proof. Let's try another one, another circle with center A and B circumference, a point on the circumference. Let me center it well. Good, that's where we have it. Good. So let me locate my chord CD. There you have it. This time I decided to make it diagonal. Then let me subtend my angle at the center A and then the angle at the circumference B. There you have it. All right, let me quickly measure the angle at the center and the angle at the circumference to see whether the angle at the circumference will be half of the angle at the center. And there you have it again. Here we have 99 at the center, and then we have 49.5, which is half of 99 at the circumference. So we take our last circle quickly. Good. So as usual, we have our center and then our chord. We subtend the angle at A, and then we subtend another one at B. All right, so we measure quickly to see what we are going to get. There you have it. The center we have 89 degrees, and then let's check the one the circumference. Let me shift it to the center. So again, that is 44.5, which is half of 89. So all these three diagrams are just to prove to us that the angle a chord subtends at the center of a circle is twice what it subtends at the circumference of the circle. And in case this is technology, so in case you have any doubt, you can construct your own circle and then draw any chord at all with a ruler. Just use a straight line, then use the ruler to subtend an angle at the center and another angle at the circumference. Make sure you use a compass to draw your circle so that you can get the center right, and measure with a protractor. You see that this relationship we have established here will be there. Thank you. Yeah, all right, so this is the explanation for the first theorem we are done. In the next video, we hope to apply this theorem to solve a question or more before we go to the next theorem. Thank you for watching, and I hope to see you again. Bye bye.